All right, Math 111, this is still exam 3 review, and I am starting on question 13, so just didn't want this video to get too long. So number 13 says, on a practical nursing licensing exam, the mean score is 79 and the standard deviation is 9. What is the standardized score of a student with a score of 87? Okay, so I said, don't go too far. I just want you to do the z-score. So if mu is 79 and the standard deviation is 9, then what was it, 87? We want to know for an 87, what is the z-score? So z equals mu, x minus mu, oh goodness sakes, x minus mu over sigma. So 87 minus 79 over 9. 87 minus 79 is 8 divided by 9 is 0.88, repeating. That's the z-score. So we would actually, on my z-chart, I would round that to 0.89, because really this goes 0.8888, right, and goes on. So if I round that, that's 0.89. All right, number 14. Suppose 15% of the area under the standard normal curve lies to the right of z. So 15% lies to the right. So I don't know, maybe that's 15%. Again, that would be the area under the curve. Is the z value positive or negative? Well, it's to the right of mu, so it must be positive. That's one of my favorite questions because it's very conceptual in nature. I like those kinds. Number 15, the incubation period for some chickies is normally distributed with a mean of 24 days. And a standard deviation of 1 day. Let's keep the math easy, huh? If 1,000 eggs are being incubated, so we have 1,000 eggs, how many chickies do we expect to hatch in 22 to 25 days? So we want to know when x is between 22 and 25, how many? So what we do is we find a percentage, we find what's that probability, and multiply times 1,000 eggs to find out how many actual eggs we'll get. So a z for 22, a z for 25. So x minus mu over sigma, 22 minus 24 over 1, that would be negative 2. Ones are beautiful, aren't they? 25 minus 24 over 1 equals 1. So the probability that x is between 22 and 25 can be calculated by the probability that z is between negative 2 and positive 1. So the probability that z is less than 1 minus the probability that z is less than negative 2. So that probability that z is less than negative 1, and I did not pull my chart up, and I didn't make a lot of notes. So let's open my fancy chart here. My z chart right there. Oh, I think it's this one I like. So the z chart or the probability when z is less than negative 2 is 0.0228. Let me scroll down to positive 1. That's 0.8413. 8413. And if I do 0.8413 minus 0.0228, That's 0.8485. 0.8485, that's that percentage. When I multiply that times 1,000, I get 848.5. Make sure I grabbed all the rate values. Yep, looks like I did grab the rate values. So, wait a minute. Did something wrong. What did I do? Negative 2.0228. Did I do that right? 0.8. Oh, I do have a typo in my calculator. I apologize, guys. I typed it wrong on my calculator. So 0.8413 minus 0.0228 gets 8185. So then when I multiply times 1,000, I get 818.5. Probably could argue whether it's 818 or 819. It's hard to have a half a check. So that one I could probably argue either way. I would not try to trick you on something like that on a test, so don't worry. Eventually. All right. Number 16. Find the area under the standard normal curve over the specified interval. This one is just a simple finding the probability. So the probability that z is between negative 2.6 and negative 1.3. This is basically what we did on that worksheet we did when we started 7.2. So this is just finding that probability. That probably, I'm going to do this one quickly, is 0.092. But how do I get that? So the probability that z is less than negative 1.3 minus the probability that z is less than 2.6, negative 2.6. Let's look those up on our handy dandy probability chart. So negative 1.3, oh, it's just negative 1.3 is 0.0968. 0.0968. Negative 2.6. Let's see, 0.0047. 0.0047. And that value is 0.092. 0.092. That's your answer. So again, we're just simply finding that z interval. All right, so number 17 is one of my favorite questions to put on here. The binomial probability distributions depend on the number of trials n of a binomial experiment and the probability of a success p, little p, on each trial. Under what conditions is it an approximation to the binomial? Sorry, I think I was missing a word. The answer is n times p must be greater than 5, and n times q must be greater than 5. Okay. Tune back into, I think that's 8.3 perhaps, if your that lecture had some more information. All right, so number 18, 19, and 20. Let's get a clean board so that we can get started. So 18, total plasma volume is important in determining the required plasma component in blood replacement therapy for a person undergoing surgery. Plasma volume is influenced by the overall health and physical activity of an individual. Suppose that a random sample of 45 male firemen, okay, there's my N, is 45. Male firemen are tested and they have a plasma volume sample mean, so it's X bar, of 37.5 milliliters per kilogram. Seems like a funny unit, but that's just how they measure it. Assume that sigma equals 7.5 milliliters per kilogram for the distribution of blood plasma. Number 18 says, find a 99% confidence interval, so we need 99% confidence interval for the population mean blood plasma volume in firefighters. What is the margin of error? So remember my margin of error? Now, how do I know if it's T or Z that I'm using? It gives us sigma. So we know that we need to use Z. So error equals Z sub C, sigma divided by the square root of N. How do I get that Z sub C? Let's flip over to my handy dandy Z chart. And if I scroll all the way to the bottom, I find this handy dandy little chart. And 99% is 2.58. So that's my Z score, is 2.58. So in this case, Z sub C equals 2.5. You might notice that sometimes I use an arrow instead of an equal sign. This is not equal. This is the Z sub C for that. There's a connection there, but it's not equal. So I'm always careful about using equal signs. And then I need to calculate the rest. I have my sigma, which is 7.5 over the square root of 45. Right, so that error is 2.88. Okay, that's the error. And I want to do a confidence interval. That's the other part of this. What is the confidence interval? How do I do a confidence interval? X bar minus the error is less than the real mu, which is less than X bar plus the error. So what was X bar? It was 37.5 minus the 2.88. Now you'll notice I just rounded in the middle of a problem. Honestly, if I was doing it myself, not in front, not on the board like this, I would redo this calculation. The other thing you can do is just keep extra decimal places. So 37.5 minus the 2.88 is 34.62 less than mu, which is less than 40.38. That is my confidence interval, okay? That's the confidence interval. So when they ask that question, that's what we're looking for. Number 19 says, what are the conditions necessary for your calculations? And I said, and assume we're in section 8.1, which we are. That is from 8.1. Sigma must be known, and N has to be greater than or equal to 30. So we knew to use Z because sigma was given, but because we weren't told it was normally distributed, but because N was greater than or equal to 30, we were all set, okay? I don't think we were told that it was normally distributed. No, it doesn't say they're normally distributed. And then the last part says, what is, give a brief interpretation of your results in the context of the problem. There is a 99% confidence, or this 99% confidence interval is one of the intervals that the population average blood plasma level for male firefighters, okay? So we're 99% confident that this interval that I calculated is an interval that would work with this situation, okay? So number 20, find the sample size necessary for a 99% confidence level with a maximum error estimation of 2.50. So this is saying, okay, we want to study this, but we don't want more than a 2.5, milliliters per kilogram error, right? Because that's important, life or death, kind of important. And I want to be 99% confident. How many firemen do I need to sample? Was 46 the right number, or is there a different number? So I'm going to use, so this is number 20, I'm going to use N equals Z sub C sigma over E In this case, because we have, because we're talking about the Z and T, we can do the calculation this way. Again, that formula is on your formula sheet. It is simply the error formula reorganized, but it's all done for you. So what is Z sub C? We already looked up 99%, so 2.58. My sigma is still 7.5. So it's that same sigma. And then the error is 2.50. Sorry, I'm writing kind of funny. And then I need to square that whole thing. So that would probably be the biggest reason people get it wrong is they forget to square the whole thing. So 59.9076, and that translates to 60, right? Because sample size, we always round up, because the bigger the sample size, the better the information. Okay. All right, let's do another one. We're getting close here. There's one more page. Okay, that's not the page. Let me flip over. You'll see posted in Canvas something that says extra page. When I scanned this, I just goofed. So someday I'll rescan it, maybe rewrite it. All right, so what, just a second, where am I? What are the conditions? Oh, we already did that. Sample size, okay, we did that. Number 21, it says, do you want to own your own candy store? With some interest in running your own business and a decent credit rating, you can probably get a bank loan to start on startup costs for franchise such as Candy Express, the Fudge Company, Caramel Corn, and Rocky da-da-da-da. So again, this is from 8.2. I wouldn't tell you that on the test, but I do on these practice exams sometimes. You are given, again, we're on number 21, you're given some raw data. You have to calculate X bar and S, so it would be S, not sigma. And then I asked you what is the degrees of freedom and what is T sub C. So when I do my X bar calculation, I find that it's 10 point, I can't read it very good. Oh, 106.8889, 106.889, that's X bar, and then S is 29.44. Again, use your calculator, use Excel, whatever works for you. And then T sub C for this one is 1.860. So I go to my T-chart, my degrees of freedom, let's see, N is equal to 9, so my degrees of freedom is 9 minus 1, which is 8. So when I have that information, and does it tell us, oh, 90%. So 90%, we can calculate this. All right, so this is number, what did I say, 21. This part was part A. These two were part A. Part B is actually finding the error. So the error is T sub C, S divided by the square root of N. Remember, it's N, not N minus 1. Keep track of that. It's easy to goof on that. So my T sub C is 1.860. S was 29.44. And N is 9. Try to keep the math good here. So that error calculation is 18.2528. So how do I do an interval? It's X bar minus the error is less than mu, which is less than X bar plus the error. What was X bar? 106.8889 minus 18.2528, which is less than mu. X bar is 106.8889. And again, I just kind of extended my decimal places. I just tried to keep a bunch so that I'm not rounding in the middle of the problem, or not rounding significantly anyways. So I get 88.64 is less than mu, which is less than 125.14. Okay, so that's my confidence interval. So what does it mean? It means we are 90% confident that the computed interval is one that contains the population mean startup cost for candy store franchise. So we all could guess that doing a startup of a business, maybe some of you have tried it, it's always more than you expect, right? So they're saying, here is the interval of what the mean is, right? And if you don't have enough money, that could be a problem. And that's for a candy store. Kind of fun. Candy is fun. All right, get some space here. Okay, number 22. In a marketing survey, and this is our last one, so hang with me. In a marketing survey, a random sample of 101 supermarket shoppers revealed that 273 always stock up on an item when they find the item at a real bargain price. Let P, remember little p, represent the proportion of the supermarket shoppers who always stock up on an item when they find a real bargain. Find a point estimate for P. So ding ding, I think I'm in section 8.3, kind of helps me focus. So a random sample of 101, or 1,001, so N is 1,001, and that 273 always stock up. Okay, I'm one of those people that likes to stock up. That's my thing. Okay, when they find it at a real bargain price. Like I'm that lady that might buy 10 boxes of the same cereal if it's on sale. Yeah, I'm that one. Let P represent the proportion of all supermarket shoppers who stock up. So that's why R is success. What is a point estimate for P? Well, it's P hat, and it's R over N. So 273 over 1,001, which is going to be close to 2.73. So let's see, or 0.273, 0.27. That's my point estimate, so about 27%. And my error, remember my error formula, is Z sub C times the square root of P times 1 minus P, or Q, however you like to write that, over N. And really that's P hat because that's what we have, right? So that's my error formula. They want a 95% confidence interval. So my Z sub C for 95% is 1.96. So I do 1.96 times the square root of 0.27. Now, again, this is where I would really do 273 over 1,001 times 1 minus 273 divided by 1,001, okay, divided by N, which is 1,001, okay. I would do that so that I'm not rounding in the middle of this problem. That error is 0.028. So my error is 0.028. As we've talked about before, I would expect that value to be small. And then to find my confidence interval, I take P hat minus the error is less than P, which is less than P hat plus the error. So P hat was 0.27. Again, really I should write it out. I should do it the long way. 273 divided by 1,001 minus whatever this error was. I'm going to round the error for the sake of writing it out. 0.028 is less than P, which is less than 273 over 1,001 plus 0.028. So that interval is 0.24 to 0.298. So 0.24 is less than P, which is less than 0.298. Okay? And then again, what does that mean? Okay, so a recent study showed showed that 27.3% of all shoppers stock up on supermarket bargains with a margin of error of 2.8%. All right, you guys are gonna do well.